Good day everyone! Welcome to the world of mathematics. So in this video, we will learn important things and those are about pre-calculus and basic calculus. So math is not that hard actually. So don't be discouraged or confused right away because I am here. Teacher Ella will help you understand each lesson in this subject. So without further ado, let's start our discussion.
Have first the daily reminders. First is if you think that you can't understand the lesson because of the pace or because the pace is fast for you, kindly pause if you need to or kindly pause the video. Next is much better if you have ball pen and paper or notebook with you so that you can jot down all the concepts or important concepts and formulas that we will going to use for this lesson. Okay, so lesson number 4 is about ellipse. So let's start. For our objectives, we have first one is analyze the parts of the ellipse. 2 is to solve real life problems involving ellipse. 3 is to demonstrate willingness in finding solutions in every problem encountered. So let's define what is ellipse. So ellipse is a regular oval shape traced by a point moving in a plane so that the sum of its distances from two other points or the foci is constant. So this is an example of ellipse. And let's have the different parts of the ellipse. First is we can graph the ellipse horizontally. So horizontal ellipse and vertical ellipse. Let's have first our okay. First part is the center. Again, center is the point in the middle of the ellipse. So in ellipse, the center is denoted HK. And as you can see, we have 2 points here. One on the left side of the center, one is in the right side if the ellipse is horizontally, and if the ellipse is, as you can see, in vertical, we have 2 points here, which is in the upper part and the down part or the lower part that is called foci. So you can call it foci or foci. It's up to you. And when we say foci or foci, this is the plural form of focus. So meaning in the ellipse, we have two focus. And as you can see, we have here, again, focus 1. It can be focus 1. And we have focus 2. Again, ellipse has two focus or has foci. And the distance between the two is 2c. So this is the formula and finding the distance between the focus 1 and the focus 2, 2c. Now, if the question is, what is the distance from the center to focus 1? The answer is C. The same with from the center to the other focus is still C. And again, the distance between the two, that's 2c. Okay? Next one, the latus rectum. So when we say latus rectum, this is the chord that pass through the foci. So perpendicular, or it's perpendicular to our major axis. So that's latus rectum. Next one. Next part is the vertices. Okay? So when we say vertices, that is the end point of our major axis. So when we say major axis, that's the longest chord that pass through the foci and center of the ellipse. So major axis can be denoted as 2A. Always remember that, 2A. So when we say 2A, that's the length of the major axis, or that's the distance between the vertices. So when we say vertices, this is the plural form of vertex. So meaning again, in ellipse, we have also two vertex. So we can say vertex 1 or vertex 2. So the distance between the two is 2A. If the question is, what is the distance from center to one vertex only, we have A. The same with the other side. Center to the vertex, we have A. In summary, we have again, major axis is 2A, or the length of the major axis, or the distance between the vertices is 2A. So always remember that one. Next one is the covertices and the minor axis. So covertices and minor axis is the opposite of major axis and um, the vertices. So major axis is the longest chord that pass through the foci and center of our ellipse, while minor axis is shorter than the major axis. And as you can see, it only passed through the center, only in the center. Okay, then the end point of our minor axis is known as covertices or covertex 1 and covertex 2. Okay, so that's the difference between minor axis and major axis, and the vertices and covertices. The vertices is the end points of major axis, while the covertices is the end points of the minor axis. Okay, so minor axis can be denoted as 2b, or this is the formula in finding the length of the minor axis, or the distance between the covertices. So if the question is, what is the distance, or what is, or how can we denote the distance from the center to one or to the covertex? So we have B. Okay, the same with the other, from center to the other covertex, also B. And again, the minor axis, the length of the minor axis, or the distance between the vertices is 2b. And always remember that A is greater than B. Next one, the equation of ellipse. So the equation of ellipse has two forms, which is in general form and standard form. In general form, we have ax squared plus cy squared plus dx plus ey plus f equals 0, where a, c, d, e, f are constant. So take note that in the equation of the ellipse, a must not be equal to c, and a, or small letter a, is greater than b. So let's proceed to the standard form. So we have two. Standard form, if our center is at the point of origin, or 0, 0, we have two equation. So first is equation is, we have x squared over a squared plus y squared over b squared equals 1. So we can use this equation if our major axis is located at the x-axis, or the graph of the ellipse is like this one. Okay? So you can see, again, the center is located at the point of origin. Now, let's have the second equation. So we have x squared over b squared plus y squared over a square equals 1. So we can use this equation if, again, our center is 0, 0, and the major axis is located at the y-axis, which is here in the figure number 2. Again, the center is in the point of origin. Next is the standard form if the center is at HK. So we have two also. The first one is we have the quantity of x minus h square all over a square plus the quantity of y minus k square all over b square equals 1. So we can use this equation if, again, the center is HK and the major axis is horizontal, like in the figure number 3. Okay? So our major axis here is horizontal. Again, when we say major axis, that's the longest chord in the ellipse which passes through the foci and the center of the ellipse. Now, let's have the second equation. So we can use the quantity of x minus h square all over b square plus the quantity of y minus k square all over a square equals 1 if, again, the center is hk and the major axis is vertical. Like in the figure number 4, as you can see, our major axis or longest chord that passes through the foci and center is vertical. So always remember the different um, equation or the general form or the standard form because we will need it. It depends on the given problem. Aside from equation of the ellipse, we need also to remember the key formulas. The first one is, again, the center of the ellipse is HK. Always remember that. Then, in finding the area of ellipse, we have the formula, which is pi. Okay, so this is pi AB. Wherein, again, the A is the distance from the center to the vertex, while B is the distance from the center to the co-vertex. Now, let's proceed to the length of the major axis. So I've already discussed this earlier. So in finding the length of the major axis or the distance between the vertices, the formula is 2a. Next is 2b. So 2b is the formula in finding the length of the minor axis or the distance between the co-vertices. Next formula is 2c. So 2c, we can use this if we need to find the distance between the focus 1 and focus 2 or the distance between the foci. And C is the distance from center to the one focus or the focus 1 or focus 2. Then another is in finding the length of the latus rectum. Again, when we say latus rectum, this is the chord that passed through the foci which is perpendicular to the major axis, which is we have the formula 2b square all over a. And we have c square equals a square minus b square, and E is equal to C divided by A. So we can use this equation, or sorry, we can use this formula C square equals A square minus B square in finding, let's say, for example, the value of A, the value of B, or the value of C. Okay? Always remember, again, the formulas and the equation of ellipse. So let's have the example. So in problem number 1, FCPC has an oval field that has a foci at 0, 1 and 4, 1 with a major axis of 6. Now the question is, or the question are, number 1, what do you think foci or major axis means? Number 2, what is the center of the oval? Or what is the center of the oval field given the foci and major axis? Number 3 is what is the value of A, C, and B? And number 4 is what is the equation of the given ellipse? So before we proceed to the explanation of each question, let's have first the problem one, or let's analyze the problem one and identify the given. So according to problem one again, the oval field has a foci at 0, 1, and 4, 1. Meaning we can say that this 0, 1 is our focus 1 and focus 2. And we also have focus 2. And we also have the given major axis of 6. Again, we have the given major axis and foci. So for us to really understand or visualize our problem number 1, we can plot the foci on the Cartesian plane for us to see what is going on in the Cartesian plane, or what is our ellipse, what are the parts, right? So foci 1 is again 0, 1. So this is the focus 1, focus 1. Then 4, 1. So 4, then 1 is our focus 2. So we can now visualize, or we can now see the location of our foci. Now, let's proceed to our question number 1. So in question number 1 is, what do you think foci or major axis means? So earlier, I've already discussed this one. So when we say major axis, this is the chord or the longest chord inside the ellipse that passes through the foci and the center. Okay? Chord that joining the vertices, foci, and the center. Okay? When we say foci, these are the two fixed points of an ellipse. Let's have question number 2. So what is the center of the oval field given the foci and major axis? So first is we need to plot. So we already plot that one. So we have here. And we will find the midpoint of the two focus. When we say midpoint, that's the middle of the two focus. So we can easily locate it once we plot our foci. So the middle is this one. So this is our center. So if you can't plot the points, you can also use the midpoint formula, which is, I will just write it. So when we say midpoint formula, we have x sub 2 plus x sub 1 all over 2, comma, y sub 2 plus y sub 1 over 2. So it's either of the two. You can plot the foci, then locate the midpoint. It's up to you. Or you can use the midpoint formula to be precise. Again, it's up to you. So using the midpoint formula, so we have foci 1, or sorry, focus 1 is 0, 1. So let's write it down. Focus 1 is 0, 1. And focus 2 is 4, 1. So we will just substitute our ordered pair. So x sub 2 is 4 plus x sub 1, 0, 4. Divided by 2, we have 2. Next is y sub 2 is 1 plus y sub 1 is still 1. So 1 plus 1 is 2. Divided by 2 is we have 1. So again, our center is 2, 1. If we will use the midpoint formula, or we can plot this one, the foci, then locate the middle of it, or the midpoint, it's up to you. Okay? The center is again located at 2, 1. Now let's proceed to question number 3. So in question number 3 is, what is the value of A, C, and B? So let's have a quick recall. Again, when we say A, this is the distance from the center to the vertex. And when we say C, this is the distance from the center to the focus. And when we say B, this is the distance from center to the co-vertex. Okay, so I hope it's clear to you. So let's have first C. Let's find the value of C. So the value of C is equal to 2. Why? Okay? So the value of C is again 2. Why? Because again, C is the distance from the center to the focus. So we have here focus 1 again and focus 2. So let's just count the units from center to the one focus or to the focus. We have 1, 2. So we have 2 units. So therefore, our C is 2. Next, let's proceed to A. So we have given major axis, which is 6. And we all know that the formula in getting the major axis is 2a. So we will just substitute the major axis into 2a, then the given, which is 6. So we will find the value of a. So divide both side by 2. So 2a divided by 2, that's a, and 6 divided by 2 is 3. So therefore, the value of our a is 3. Now let's proceed to the points. So since A is 3, and again, when we say A, that's the distance from the center to the vertex. So 3 units, so center to the vertex. So 1, 2, 3. So this is the vertex, and also on the left side, this is the vertex. Okay, so vertex 1 and vertex 2. Next one is the value of B. So since we have the value of C, the value of A, we can easily find the B using the formula, which is C square equals A square minus B square. So we will just substitute the value of C and A. So C is 2 from this. So 2, copy our exponent, equals our value of A is 3, then square minus B square. Now, after that, we will transpose our B. So B square equals 3 square, then transpose also 2 square. So it becomes negative 2 square. Next is simplify. 3 square is 9, or 3 times 3 is 9. 2 square is 4. So we will just copy the operation, subtraction. And after that, simplify again. 9 minus 4, that is 5. Now, we need to find the value of b. So for us to remove the square of our b here is to find the square root of both sides. So the square root of b square is b, and the square root of 5 is square root of 5. We can write it as square root of 5, or we can use our calculator to have the approximate value, which is 2.23. So therefore, the value of b is square root of 5, or 2.23. So using the value of b, we can also plot now our covertex. So our covertex here is 2.23. So we will count 2.23 units going upward and going down. Okay, so 1, 2, and 0.23. So approximately the point is here, and in the lower part we have 1, 2.23. So approximately this is our covertex 1 and our covertex 2, or our covertices. Okay, then this is our graph of ellipse using the points, using the values of our A, B, and C. Okay, let's now proceed to question number 4. So in question number 4, what is the standard equation of the given ellipse, or what are the equations? So let's have first the standard form. Okay, so we will just substitute the center, which is 2, 1, and also the value of our a square, which is 3 square, and the b square, which is 5. Or, sorry, we have typo here. This is square root of 5. And a standard equation, x minus h squared all over a squared plus y minus k squared all over b squared equals 1. So teacher, why this equation? So we will use this equation because our center is an HK, and again, our ellipse is like this. If we will go back to question number 3, so this is our ellipse, okay? So that's the graph, horizontal ellipse. So therefore, we will use the equation for a horizontal ellipse with HK center. So we will just substitute, or sorry, this b square is, sorry, this is 5, not square root of 5. So b square is 5. So let's go back to question 3. Okay? So our b square here is 5, and our a square is 3 square. Okay? So a square, so our a is 3, then the square. So sorry for that. Okay, so let's substitute going back. So our center is 2, so we will just copy. Since 2 is in positive, we will just copy 2. So x minus 2, then square, all over our a square is 3 square. So we'll just copy also. Plus, again, y minus our k, which is 1, then square all over 5, which is our b square, equals 1. After that, let's simplify the denominator since we have exponent here. So we have 3 square is 9. So the final answer, or the standard equation, is x minus 2 square all over 9 plus y minus 1 square all over 5 equals 1. So this is the standard equation of our ellipse in problem 1. Now, let's proceed to the general form or general equation. So first is, in finding the general form, we need to equate the standard equation or the standard form that we have in this one. So we will equate it to 0 for us to get the general form. So copy the standard equation. Next is we will find the LCD of the two, since the denominator of the first term is 9 while the denominator of the second term is 5. So in getting the LCD, you can multiply the two. 9 times 5, 45. So it's up to you. Or we will write the multiples of 9 and 5. So let's have a quick review on your junior high school in finding the LCD or just the common multiple. Okay, so we have, in 9 is 9, 18, and so on. 9, 18, 27, 36, 45. Then in 5 is we have 5, 10, 15, 20, 25, 30, 35, 40, 45. And the nearest or the lowest multiple of the two, or they have the same multiple, is 45. So we have 45 here. Next, in finding the multiple of 9 and 5, the common multiple is we will multiply it to the original term. Okay? So 45 divided by 9 is 5 times our the our quantity of x minus 2 square. So that's 5 times x minus 2 square. Now, next is 45 divided by 5. We have 9 times y minus 1 square. So we have 9 times y minus 1 square. Okay, so copy the operation addition, then equals 1. Next is we need to multiply 45 both sides for us to remove the denominator. So 45, okay, so let's multiply it by 45. So 45 times 45 is 1, okay? Or the remaining is this one, the numerator. So we have the numerator here. Then 45 times 1 is 45. Next, we will square the binomial first. So squaring the binomial, we have x minus 2 square, or the quantity of x minus 2 square is x squared minus 4x plus 4. So how did we come up with this one? So the shortcut in squaring the binomial is first step is to square the first term. So we will square the first term, first step. To square the first term, so x squared is x squared. Then second step is to square the last term. Our last term is negative 2. So negative 2 squared is 4. So that will be our last term for our answer. Then last step is to multiply all the values here. So x times negative 2, that's negative 2x, multiply it to the exponent 2. Again, multiply only, not raise to 2. So negative 2x times 2, we have negative 4x or minus 4x. So this is the answer and squaring the binomial x minus 2. Now, let's proceed to the second binomial. So we will just copy plus 9, then square our binomial y minus 1. So same step, square the first term. So y times y is y squared. Square the last term, negative 1 times negative 1, that's positive 1. Then, last step is to multiply all the values here. Y times negative 1 is negative y times 2, which is our exponent. We have negative 2y. So this is the answer in squaring the binomial y minus 1. Then copy our 45 or equals 45. And after that, distribute. So here in the first one, we will distribute 5 in the parentheses or in the values inside the parentheses. So 5 times x squared is 5x squared. 5 times negative 4x is negative 20x. 5 times 4 is positive 20. Then copy plus or addition. Then after that, we will distribute also 9 in the values or inside the parentheses. So 9 times y squared is 9y squared. 9 times negative 2y is negative 18y. And 9 times 1 is 9. Then copy equals 45. Next one. So we will combine like terms. So when we say like terms, they have the same variable and exponent. So here we have 5x squared minus 20x plus 20 plus 9y squared minus 18y plus 9 equals 45. So here, the only like terms are the constant, which is 20 and 9. So we will combine this by adding. So 20 plus 9 is 29. Now, we will just copy 5x squared. So since we don't have like terms, also minus 20x, then the 9y squared, and minus 18y. Then equals 45 again. Then equate to 0. So when we say equate to 0, we will transpose, or sorry, we will transpose 45 to the left side, or we will subtract 45 both sides. Okay? So minus 45 in the right side, minus 45 also in the left side. So 45 minus 45 is 0. Then copy. Then minus 45 at the end. Then simplify. The constant here is 29 and 45. So subtract. The final answer is 5x squared minus 20x plus 9y squared minus 18y minus 16 equals 0. So this is the general form or general equation of our ellipse in problem number 1. Okay? Now let's proceed to problem number 2. So I hope in problem 1 there's no question anymore or clarification. Again, you can rewatch this video if you can't understand the lesson because of the pacing. Okay? Problem number 2. What is the general equation of an ellipse-shaped land with center at 2, 0 and focus at 5, 0 and B is equal to 4? Again, just like I've said earlier, in solving a problem, we need to analyze first. Okay? So we have an ellipse-shaped land with a center of 2, 0 and focus. So as you can see, we have only one focus given. So we will find the focus later, the other focus. Then we have the given B, which is 4. So when we say B, um this is the distance from the center to the co-vertex. Okay? Now the question here in problem number 2 is what is the general equation? Okay? Okay. So let's have the solution. So we can solve first for C since the center and the focus is given. So as you can see, we have focus here which is 5, 0 and center is 2, 0. So we will going to find the distance between the two or between the focus and the center. You can use the distance formula or you can plot the center and the focus. Then count the units from the center to the focus. Then that's the C. Okay? Which is C is equal to 3. After that, we will substitute the value of our C. And from the given problem is we have the value of B already, which is 4. So we will just use the equation or the formula A squared equals B squared plus C squared. So we will just substitute our C. So we have C 3, then our B is 4. Then don't forget the exponent. So A squared, 4 squared is 16, plus 3 squared is 9. So 16 plus 9, that's 25. Then for us to get the value of A is we need to find the square root of both sides. So the square root of A squared is A, and the square root of our 25 is 5. So using the equation, x minus h square all over a square plus y minus k square all over b square is equal to 1, we can now find our general equation. Okay, so we will just substitute our center. Center is 2, 0. Then we will substitute also the value of a square and b square. Then we will equate this to 0. So you can solve this one on your notebook or paper, then let's see if it has the same answer with this one. Okay? If you get the answer, then therefore you're correct. So the general equation for this is 16x squared plus 25y squared minus 64x minus 366 equals 0.
Hopefully, you really understand our today's lesson. So don't forget to practice more so that you can fully understand our today's lesson. And also, don't forget to attend your synchronous class for more examples and real life problems about our topic for today. So thank you for listening and see you on the next video. Bye!